Right, so my plan was to have a very long and boring presentation with slides and showing you figures and these kind of things. Now, everyone is showing demos, so I'm going to shrink the presentation and leave some room for a short demo of what we have to show. So we're all talking about the clouds. Now, let's imagine you're a cloud developer, you want to build your application, you want to put it on the cloud. Let's say you go on Amazon Web Services. Well, you have a number of services over there, which are fairly well understood and fairly well standardized. You have EC2 if you want to provision virtual machines. You have S3. You have a few more services. And while you know that those APIs are fairly standard, you can use Eucalyptus to access the same thing. You have a number of platforms which can implement the same APIs. Now, if you build an interesting application, something that really does something useful, you may want to use, you may see that, well, Amazon has a lot of other services. They have RDS, relational database. Oh, nice. I don't need to run my own SQL database. Just go and use RDS. You have a non-relational database. You have things for provisioning, for monitoring. And the list goes on forever, right? There's a very, very long list. Now, something which is interesting is that all the services are unmatched in any other open source platform or even commercial platform. So those services are very specific to Amazon, which means as soon as you are going to start using that service, well, you're locked in. There's no easy way to take your application and migrate it somewhere else. Why would you want to do this? Well, because that's your right. Because the pricing may change. So suddenly, Amazon may be in need of more money and may increase the prices. They may decide they don't like you in the license. If you read the license carefully, you will see that they can stop the contract at any time. They may go out of business. Their cloud may go down for whichever technical reason. There are many reasons why you want the ability to move to a different platform. So you may go and find another better cloud which has an equivalent to all those services. Now, those APIs are probably not going to be exactly the same, so you will have to refactor your application. You'll have to re-implement parts of it. You'll have to adjust to the new clouds, and all this is very doable. It just costs money and time. So this is exactly where I think we collectively can help. This is where open source can help. This is exactly what we want to do. So I'm a part of a European project called Contrail. And the goal of Contrail is to build an open source cloud platform. Maybe some of you have attended Roberto's presentation a few hours ago in the other rooms. The goal is to build an open source clouds, which is going to be built on top of OpenNebula, and we will soon also support OpenStack, with support for cloud federations. So I feel very much at home when I see all those presentations about people showing I can deploy my VMs on multiple clouds. This is exactly what we need to do in order to solve this lock-in problem. We will have support for service level agreements. So I want to be in control of the performance of my application, of course. I want to be able to specify, well, a VM at Amazon may not be equivalent to a VM at Rackspace, even though they both tell me that this is one unit. And I may also want to be in control of the protection of my data. Where is my data? I want my data, for legal reason, my data needs to be, let's say, within the European Union, because I work for governments, and the FBI must not have a way to raid the data center and take the data. Last but not least, and this is going to be the topic of my presentation today, is Contrail builds ConPaaS, which is the platform as a service environment for Contrail. So what is ConPaaS? Well, the goal is very ambitious. We want to be better than Amazon. We want to build a fully featured platform as a service environment for Contrail and for other clouds as well, with a lot of functionalities available. So you'll have application servers for static files, for PHP, for Java. We may add more. You'll have databases, SQL databases, that will be MySQL. You'll have a NoSQL database called ScalaRx. You'll have, for scientific applications, you'll have things like MapReduce or bugs of tasks, which are both runtime environment to crunch numbers really, really fast using plenty of resources. We want things to be integrated, meaning that I don't want to just have an application server here and a database over there, but I want the platform to realize, oh, this is altogether an application which is composed of multiple elements, but I will still recognize this as an entire application. We want the system to be very easy to use. I'm going to show you the GUI in just a second, but you can also script everything because everything goes through RESTful APIs, so you can script and go through command line tools. By the way, all those services I'm going to show you are largely customizable, so you can go and tweak them. Anyway, in the end, they will run in VMs that belong to you. You can have access to the VMs, you can go and change software, you can manipulate those services to do exactly what you like to do. We are going to have SLA enforcement strategies. So this is, you are going to be able to define, well, do you care exactly how fast is your database? When was the last time an end user came to you saying, well, your web application is good, but the database is slow today? So you don't care for this. What you care is for the overall application performance, what your customers are going to see, and then you're going to trust the system to do what it needs to do inside, knowing that there are all those different services and they have those relationships, and the system will provision more or less virtual machines according to demands, such that you will meet the response time you want to have. Last but not least, and that's very important in this community, you will be cloud agnostic. I am going to show you the system running on OpenNebula, and exactly the same implementation can also run on EC2. And we can have rack space, we can have more clouds. That's fairly easy to implement.